Okay, in this video, we're going to talk about slant asymptotes and rational equations. Let's start with slant asymptotes. For this function, you're already told that there is a slant asymptote. It's in the question. But if you didn't know that, remember your analysis is first to look for the presence of a horizontal asymptote. And to do that, you've got to compare the degrees of the top and the bottom. And when it's top heavy, meaning the degree on top is greater, you do not have a horizontal asymptote, but you may have a slant. And that is when the degree on top degree is greater than bottom by 1. Okay? So in this case, if your lead term is x to the 5th, and your leading term at the bottom is x to the 3rd, blah, 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 smaller degree powers, no slant. Okay? You don't have a slant asymptote, you don't have a horizontal, you ain't got nothing. Okay? So it has to be greater by 1. The top degree has to be greater by 1. And in this case, it is. Right? 2 over 1. So now, what is that slant asymptote? Okay? On the test and next quiz, you're going to have to say what it is. The answer is gotten by dividing the top by the bottom, actually literally doing what this function says. 8 negative 8x squared minus 12x plus 7 divided by negative 4x minus 4. Now, just a side note, delta math is going to say, hey, use box method or long or synthetic division to divide. Okay, box method, you'll see we don't teach that. We didn't. It's a different way of doing long division. Synthetic division works only for certain divisors. I forget which one it is, but it's only in specific cases where what you're dividing by is something like no coefficient on the x minus 3 or something like that. So it's very limited. I suggest you stick with long division. We discussed that as teachers at the beginning of the year. Stick with long division. And that's why we did it at the beginning of the year. Okay? So long division applies to all. So why not use it? And the way delta math will show you is not long division, but box method. But let's do long division. 4x minus 4 goes into, or divides into, this trinomial. Okay. Now remember, we're looking for something up here that multiplies to this here so that we get this. Therefore, your very first question, this is a refresher, is this times what will get me this? Because we want these when we do box method or FOIL, these two have to multiply to make this. And the way we can do that is by throwing in 2x, right? And the 2x will multiply to everything in the binomial. We're going to distribute that 2x to both of these terms. And by design, we, of course, get negative 8x squared. That was the point. And negative 8x. And we're subtracting, which essentially means changing the signs and adding. So when we do that, we're getting negative 4x. And we drop down everything else. All that's left is 7. But guess what? Because we're writing an equation of a line, And that equation will go y equals what this is and whatever's next. We only have one step left. In other words, the remainder, which is a standard part of polynomial long division, is not going to matter. Okay, so let's take this next step. Negative 4x times what gets me to the next piece of this? Negative 4x. Well, the answer is plus 1. Negative 4x times positive 1 is negative 4x. And again, this step doesn't really matter, but let's just complete it. Negative 4, and if we change the signs, that's 11. But this is irrelevant, because now we have the equation of a line. And you got to remember back to algebra 1, y equals mx plus b form. M is the slope, which is rise over run, and b is the y-intercept. Okay. So what does it look like? What does a slant asymptote look like? Okay, better make some little room here. But when we graph this function, it looks weird. There is if we factor this, I'm pretty sure we'll have a vertical asymptote. Probably somewhere in here. However, remember, slant asymptotes and horizontal asymptotes are about end behavior. Okay? So as the function goes to, the x of this function goes to negative infinity, this is tending toward a diagonal line, okay? And we'll never touch it, but it's going there. What is that diagonal line? We just figured it out by doing that division. It is a line that has a y-intercept of 1 and goes up 2 over 1, up 2 over 1. It's kind of a sharp diagonal line, pretty steep. Okay, that's not being drawn very well. But this line, trust me, is y equals 2x plus 1. Okay, throw that into Desmos. It'll draw it for you. But you'll see if you scroll this way and this way, the red line, which is the graph, never going to touch it. Going to get very close the farther it goes this way or this way. Okay, but that's what the nature of an asymptote. They're not to be touched. Slant asymptotes are not to be touched at the ends, the far ends of the graph. Let's do another one. This one is not, this function is not given to you in standard form, which is unfortunate because when you analyze for horizontal asymptote and y-intercept, it's very convenient. But no worries, we'll be able to figure out the leading term and therefore the degree of this just by multiplying up the leading terms of each factor. Okay, we don't have to worry about doing anything else. The rest of the box, if we do box method and multiply it out, a lot of that is a waste of time. You can just do x times x, because those leading terms will meet and you will get x squared. And then at the bottom, we can see this is the leading term. So the degree is top heavy, because that's a 1. And it's top heavy by 1, because 2 is greater than 1 by 1. Okay, so we have don't have this. Whoops, I meant to do that. We don't have that, but we do have a slant. We do have a slant because it's greater by 1 on top. All right, well, when we do long division, we need to standardize this out. So contrary to what I said, I guess you do have to multiply this out. Okay, if we do a quick FOIL, we're getting x squared plus 4x minus 6x minus 2x. And then plus 4 times negative 6 negative 24, all over negative x plus 3. All right, well, negative x plus 3 goes into this. How much? Answer is, we'll find out. Negative x multiplies to what to get x squared? I think we're going to want negative x. Okay, so this is the beginnings of our answer. Negative x times negative x is positive x squared, but this distributes. So we're getting negative 3x. And then let's change the signs and add down. This is going to be x minus 24. I don't think that's going to be relevant, but let's take this negative x. Think about what multiplies to this, and it's going to be negative 1. Negative 1. And we can stop right there because we have enough for the equation of a line. Okay? So this is going to have a negative slope. Can I spell slope? Slope. Negative slope. Okay? And the y-intercept will be negative 1. So let's see what it looks like. I know I have the graph here somewhere. I think that's it. Okay, so this is what the graph looks like. And let's see if we're kind of eyeball it and see if we're kind of right. The y-intercept would be right around there. It kind of looks right. And if we blew this up, I'm just trying to make as straight a diagonal line or a dotted line as possible, a diagonal negative slope line. So it looks like it would. As this gets closer and closer to infinity, this is likely to approach that. And as this edge, this side gets closer and closer to the x goes to positive infinity, the y is going to tend toward, well, the line, whatever it happens to be. No, negative x minus 1. Okay? And by the way, if you can see here, we have an x-intercept at negative 4. And that comes from, this is just a side note, that comes from this term in the numerator. We have an x-intercept at 6. That comes from this. Okay. And it's going to look like we have a vertical asymptote. Looks like it's going to be at positive 3. Because if I make this positive 3, the denominator goes to 0. And this is not a factor that makes a whole because it's not repeated. So, you know, it's not, Desmos doesn't draw these things for you. But it looks true to me that as this graph approaches 3 from this side, it's never going to touch the 3. And same with this side, as the graph approaches x of 3, as x goes to 3, the y plummets down to negative infinity. Just does not want to touch that negative 3 since it's not allowed. 3 is not allowed. Okay, 2 examples. Now, let's talk about rational equations. Switching gears, this is not a graphical type of problem, but this is a rational expression because it's a fraction. And we're doing kind of problems and skills related to this. So if you're going to solve for x, and you have one rational here and another rational here, what you're going to want to do in order to solve is get the denominators to be the same. And watch how we do this. This is a denominator, that's a different denominator. If we want them to be the same, and you remember this from doing complex fractions, we should give this a double dose of x's, give this a double dose of x minus 7s. That way we're multiplying by 1. And now we have the same denominator. And guess what? Now we can eliminate the denominators and just focus on the numerator to solve. Okay. That's a principle of solving rational equations, that you want to get denominators all the way through. And to do that, you end up changing the numerator. But then after that, you can ignore them. Now, some of you may have been thinking to yourself, to solve this, couldn't I have done cross multiplication? And the answer is yes. So cross multiplication means you go across from numerator to denominator. Numerator to denominator. And these crosses are what gets multiplied. X plus 3. Okay, that's this and this. On the other side, we get negative 2 times x minus 7. Well, look over here. Look over here. We've done the exact same thing. Okay, so cross multiplication is a shortcut way of getting the same denominator all throughout your equation. Okay, but don't stop here. We got to solve for all values of x. So what we're going to do is, we're going to distribute the x here, and then we're going to distribute that negative 2. But as soon as we do this, as soon as we multiply everything out and take a look at it, we need to notice, look at that power. That's the highest power in the land. That means we are solving a quadratic. This is a quadratic equation. Had it not been for that power of 2, we'd have a linear equations with just plain x's, very easy. This is also easy, but it's a different approach. Okay, and the approach is this. You're going to remember this from Algebra 2. Remove. Good afternoon. Could all custodians remove everything on this side of the equation, okay? And to remove that, we're going to add 2x to both sides. And that means it's going to be 5x over here when we add it to this. And we're going to subtract 14 from both sides. So a negative 14. This is what we got, okay? This is what we got. We want to zero out one side of the equation and shove everything on this. After we've done that, we are going to factor. We're going to factor this. Let's see, these have to have different signs because I'm multiplying to negative 14. And because I'm multiplying to negative 14, different signs, I need two numbers that subtract to the 5. And the bigger of the two numbers is going to be my positive because I want positive 5. Okay. So we've just kind of rewritten this original equation to this. And now, very easy to solve. You can tell, right? Because this is called, I never gave a name to this, zero product property. If I make this 0, I win the equation. If I make this factor 0, I win the equation. These are my two answers, okay? The last thing that you should really do, this is a technicality, is make sure that these values do not make the denominator 0, okay? And it doesn't, right? Positive 7 would, but we have an answer of negative 7. And x equals 2, not a problem. So we've got two answers. Okay, and this is the last. This is kind of, it's the same idea. It's the same idea, just configured a little bit differently. Okay, we're going to make this side a fraction with a denominator of 1. Okay, if you want to think about that shortcut, numerator, denominator, cross multiplication, what you're going to get is x minus 3, x plus 1 on this side, And on the other side, it's just multiplying to 1, so it's kind of left there. So multiply this out. Negative 3 plus goes like that. 0 out this side. Subtract x from both sides. Add 5 to both sides. Okay, this will be 0 by design. We'll have x squared plus x plus 2. I just noticed a mistake. This should have said minus 2x because it's negative 3 plus 1. So negative 2x minus x is negative 3x plus 2. That makes this actually factorable, because before it wouldn't have been factorable had I not caught that mistake. Okay, so back to zero product property. This will satisfy the equation, and this solution will also satisfy the equation. And neither of them will cause a problem if we plug them into this denominator. So here are our solutions.